Hello, I'm Jan Rybicki of the Jagiellonian University in Krakow, Poland. And of course, sadly, I cannot be here with you. I'm still in Krakow, Poland. You can't see me live, but you can see me in the bottom right corner of the picture. This is a portrait of me painted by this guy Rubens. I understand that a bad copy of the painting is in Madrid in the Prado, except that for some strange reason, some hack has painted over my face with that of one of your kings, Philip II. I don't know why people desecrate works of art like that. But we're not to talk about art today. We're to talk about stylometry. So let me give you a gentle introduction to this. The stylometry is really easy to define. It's just counting anything that can be counted in texts for different reasons. As you can see from this first list here, this has been done for quite some time. For various reasons, you can see that mostly stylometry is a tool for discovering the author or authors of texts, for plagiarism detection, which is obviously associated with that. You can see that there's all kinds of things you can count in texts, like figures of speech, word length distribution, sentence length, word types and tokens, words and sentences and syllables, letter engrams, and very characteristic words, which is probably the most traditional way of looking at authorship attribution. Now, the stylometry works best if it has a lot of data to work with. So these methods of stylometry usually are considered to be the best ones, which operate on large texts. This is why you will mostly find stylometry done on novels, at least in literary studies, because novels are big, nice chunks of texts in one place. It also pays to use a lot of texts. And perhaps the most important thing to get any sort of statistical significance, to get any reliability of what you're counting, it's usually a good idea to count things that there's a lot of in the texts you're looking at. And one of those features are very frequent words. Now, why very frequent words? First of all, because they are very frequent, because there's such a lot of them. However, in literary studies, most frequent words in any text were not really something that literary scholars looked at. It took John Burroughs in 1987 to explain to the literary scholars that half of every book they've ever read and analyzed is composed of very, you would say, insignificant words. Half of every book is 100 most frequent words, none of which are really very meaningful. They are most of this linguistic mud, like personal pronouns, auxiliary verb forms, prepositions, conjunctions, etc., etc. Now, the reason why, theoretically, this should be working in literature is listed on this slide. Apparently, we can suppose that frequency patterns of very common words are significant because those very common words do not function alone, obviously, because they, in a way, define the context of the entire text, define the context, are the context for those more meaningful literary words. Also, at this point in any discussion of stylometry and authorship attribution, the stylistic fingerprint metaphor is used. When we look for the culprit of a crime, and we use dactyloscopy for this, the feature of the criminal that we're looking for is not very meaningful, doesn't really tell us much about what kind of person he or she is. We are just looking for something that would identify this person best. The fingerprint then, or the DNA, which doesn't have a lot of common with the deeper nature of any person. So the first probable use of the usage of very frequent words was a very interesting case done by Mosler and Wallace in 1964. They were trying, and they successfully found, the authors of certain articles and pamphlets written in 1787 to 1789 in America. They compared a number of methods for authorship attribution, and they found that the most reliable one was the one that used function words. Now, function words is just another name for very frequent words. Most of the very frequent words are in fact function words. So let's look at those beautiful function words. Here's one in Spanish. Oh, by the way, I don't speak Spanish, so I hope this list makes sense. Well, when we talk about making sense, it's not really, there's not a lot of sense here. I don't really think there are very many content words, meaningful words here. Well, I can see doña, I can see hombre, but that could mean anything. As you can see, the first 100 most frequent words in any language, here's English, and if you want, here's Polish too. Well, those 100 most frequent words, they are very boring, which means, of course, that half of every book, because that's, as I already said, this is the extent of the appearance of those most frequent words in any book. Well, all those, half of every book is really, really boring linguistic items. Sorry about that. However, those very frequent words, as you will see, are very useful in stylometry and authorship attribution. So I will be presenting to you one technique of stylometry, a package for R, written by Maciej Eder, Mike Kestemon, and marginally by myself. We already have been around for 12 years. The first version of the package was written by Maciej when we were returning from a summer school in Leipzig. It was a long train ride to Krakow. The computational stylistics group is an absolutely informal group of scholars who it's been growing slowly, and it's been working with and around Stylo. You will find everything about the group on our GitHub website. Stylo is now at version 0.7.2, so you can see we're sort of taking it slow. More detailed instructions about Stylo are on this subpage at GitHub as well. Obviously, this is where you can find the installation instructions, the latest versions, and many other things, including resources, some examples of scholarship, etc., etc. Okay, so let me give you a quick walkthrough how to do things with Stylo. First of all, you need to compile a set of texts on which you will be working. These texts can be in any of the three formats: plain text, HTML, and XML. Stylo reads them all. Usually it's best to follow our favorite convention of naming the text. This will be explained later why exactly this is the way we want it. Usually the file names should contain the name of the author, the underscore, and then, for instance, a part of the title. Obviously, this will be later displayed on graphs, so it's a good idea to keep the names of the text fairly short. Then, of course, you need to create a working folder, which you can call anything you want. And inside a subfolder, which by default should be named corpus with a C, you put the text that you want to study. Now, I'm going to go on a limb here and risk my reputation working with Spanish text that I've never read, because, as I've already said, I don't read Spanish, nor even speak it. We have here 4 texts by Galdós, 3 by Ibáñez, and 2 by Unamuno. You will see a moment later why those texts and why so few of them, but that's another story. So once we have this done, you can see that the names of the texts actually do follow our guidelines. You actually have a little more metadata in the file names, the date of each of those books. Once you have that, you can well, if you're doing it for the first time, you have to install R. Then you have to run it. Then you have to install Stylo. That is done just once with the command install.packages, etc. Then you need to load Stylo with the command library Stylo. We're, of course, working in R right now. And then the last thing in this preparatory stage, you have to tell Stylo where your working directory is, either by the R command setwd or using the graphic user interface and changing the folder. That's all fairly straightforward. And then we finally get to run Stylo with the command stylo bracket. And as you can see, Stylo owes some of its popularity among the stylometrists, among the humanists who work with stylometry, is that it's cheating R out of its fairly steep learning curve by using a very detailed, if ugly, graphic user interface. I can say it's ugly because I'm the one who designed it. This is where we set our parameters, and once that is done, we can press OK, and things will start happening. Of course, if you need, we can look at how this is done in real life in the later session, where I will appear live this time. So once we press OK and your computers don't blow up, we can sort of count on Stylo to do the following things. It will read all your texts that you put in the corpus subfolder of your working directory. Of course, you can call that subfolder anything else, but then you would have to tell Stylo that name. If you don't, Stylo simply assumes that all your files are in the corpus subfolder. I think that's a neat trick. Then, of course, all texts have to be cut up into separate words. Those words have to be counted. First of all, to produce this list of most frequent words for every collection of texts that you're working with at a given time, which is exactly what happens here. And then you also get frequencies of those most frequent words. and you see their frequency in any of the texts. The table that you see here only has, I think, 9 Spanish words, and the numbers here are already relative frequencies, because obviously we have to somehow realize that books tend to have different lengths, and so it's a good idea to use relative frequencies rather than raw frequencies. As you can see, the results for each of the texts are fairly similar, so it's not perhaps anything a human could do with that table that could be made interesting at all. So the next stage in Stylo is to use a measure of distance. This is one of the most favorite ones that we use now, the cosine delta, it is called. To use a measure of distance, in fact, a measure of the similarity between pairs of texts. And this produces a distance matrix, or simply a table of distances between texts, which usually has one universal characteristic. If you look at these numbers, and again, the numbers show the degree of distance, the degree of dissimilarity between the texts. Well, obviously, the similarity between the same book, the dissimilarity between the same novel is 0. But when you look at the other values, you will see that more often than not, that in fact in almost all cases, this distance is smallest between texts written by the same person. And this is, well, usually a fact of life. These long lists of very frequent words and these long lists of their frequencies, they are usually very similar between texts written by the same author. And this is something that is perhaps intuitively acceptable, but we sort of don't really have a lot of theoretical linguistic support for this. Still, it is an empirical fact. Now, once we have a distance matrix, by the way, those tables do not appear at all during the process. You can retrieve them later from the program, but that's another story. Once we have such a distance matrix, we can make Stylo grow a tree. Now, this is what we call a cluster analysis tree. Well, this tree has fallen. It's horizontal, as you can see. The main trunk is here, and here are the branches. Now, what cluster analysis does, it looks at those distances and manipulates them in such a way to put the most similar texts on the nearest branches. This is why it's also called a nearest neighbor analysis. Now, here we can see that of all the texts by Ibáñez, they are always very similar to all the other texts by that author. And 3 out of 4 texts by Galdós also stick together. Well, I will not hide it from you. That doesn't look very good. La Sombra by Galdós, for some reason, is a little more similar to the 2 texts by Unamuno than to Galdós. Does this mean stylometry does not work? Well, not really, I hope. What happens is, perhaps we need to change our parameters a bit. You can see that this analysis was done for 100 most frequent words. Well, let's see what happens if we take 200 words. Much better. Now our attribution is perfect. And what is more, if we now had a book written by any of those 3 authors, and we wouldn't know that who the author is, Well, we can tell it on good authority that this would show us who the real author is by placing it on the right branch. Let's see what happens when we take a little more words, like 500. Still pretty good. Uh, and we can even do it for 1,000 words. Uh, by the way, you might have noticed that uh, while some positions of the text on this tree change, uh, well, we do sort of have some universal results. Among other things, uh, Unamuno seems to be more similar to Galdós than to Ibáñez. Now, I know nothing about Spanish literature. I don't know whether that makes any sense, but perhaps you do. And you can tell me that after I'm done and we come on live. Okay, the question is, which of those trees should we put in our brilliant publication that we make out of this analysis? Obviously, perhaps we wouldn't want to use this one, but then to pick just one would be cherry picking. Now, what do people do if they cannot decide, if they're civilized? Well, they vote. So, in fact, there is another little method which Stylo can use, which is taking a number of different results, pulling them together, where all those results sort of vote for the most popular connections. And this is called a bootstrap consensus tree, which is a result of individual cluster analysis at 100, 200, 300, 400, 500, all the way to 1,000 most frequent words. And here we can see a very consistent pattern. And obviously, in general, our authorship attribution is perfect. And again, this long distance here shows that while the three authors have their own little groups, their own set of branches, then Galdós and Unamuno share the same branch, while Ibáñez is a little further away. Okay, that seems nice. Now, let's look at some real life cases that were solved. You might remember a couple of years ago, that was very big in the news. There was a rumor that thrillers written by a person called Robert Galbraith were in fact written by J.K. Rowling, the much more famous author of the Harry Potter novels. This diagram, this bootstrap consensus tree, shows that indeed, at least in comparison with some other books about undemocratic private schools, like Enid Blyton, and fantasy books like Tolkien and Lewis, and thrillers like Cobbin, well, at least in comparison with those, the text by Rowling and the text by Galbraith have their own branch. You can also see that there is a separate sub-branch, so to say, for all the horrible Harry Potters, while another book for grown-ups written by Rowling under her own name sticks very nicely with Galbraith. The first person to discover this was, in stylometric terms, was my friend and colleague Patrick Uola. Another case study. Here's a close-up on what I wanted to show you. Another case study is one I did with my two colleagues, Michał Hoński and Maciej Eder, was concerned Harper Lee. Harper Lee has long been thought to be only the author of one book, a very famous book, To Kill a Mockingbird. Just before her death, another book was published, Go Set a Watchman, and the media went wild. There were all kinds of conspiracy theories about Harper not writing Go Set a Watchman, about Harper Lee not writing To Kill a Mockingbird. Well, to make a long story short, we just put Harper Lee's two books with some Southern authors, including Truman Capote, who in fact is a character in To Kill a Mockingbird, and who has been looked at in terms of possible authorship or co-authorship of To Kill a Mockingbird. As you can see, thank God, perhaps, Harper Lee is obviously the author of both books. In fact, as it became eventually clear, Go Set a Watchman is a very, very, very early version of To Kill a Mockingbird. So this result is only showing the obvious. Another case would be of French literature, and well, you can see how beautifully those French novels present their authorship in the most beautiful way. There's not a single misclassification here. Zola is Zola. He's separate but similar to Flaubert. We have a separate branch for Jules Verne. We have Dumas, different from Dumas Jr. We have a little Proust. We have a Balzac branch, etc. Now, let's see what happens. And by the way, we're entering my favorite territory. Let's see what happens if we now take the same novels, except if we take them in English translation. Okay, you cannot see that very clearly because there's a lot of those translations. You have to take my word for it, however, that these are translations of just the books included in the previous graph, right here. Well, while we cannot very well read the names of the individual books, the colors, different color, of course, is for every different author. The colors tell us that except for one little Balzac group, the authorship attribution is still perfect. Okay, let's think about it. What words were used to obtain this result? Well, very frequent words, but not the very frequent words that the original authors chose. No, these were very frequent words in a different language, in English, chosen, I would say, at least with some freedom, and obviously often very unconsciously, by the very different translators that appeared here. And still, mysteriously, the texts in translation prefer to stick by the original author. I still don't know why this is happening. I'm trying to find out, but it's been a long time. Speaking of translation, remember my little Spanish experiment? Well, here are again the same 9 books by Spanish authors, except that now I've been able to find their Polish translations, and let's see what happens. Well, we still get one error at 100 most frequent words. This is another Galdoth book. Apart from that, however, even when those books are, if you want, converted into a very different language like Polish, we're still only getting a single misclassification. Let's see what happens at 200 words. And now it's perfect. Whoa, that's very weird. Let's see what happens at 500. still very nice, except for one thing. Now it's Galdoth and Ibanez who are more similar to each other. Remember, with the originals, Ibanez was the outsider. At 1,000 most frequent words, things get a little more complicated. Now Galdoth is divided into two different groups. One of the reasons why half of the Galdoth texts refuse to stick with the other half is perhaps this. As you can see here, those two texts were translated by the same translator, which might tell us that after all, the signal of the translator, if this is how we decide to call it, is also visible in stylometric analysis, perhaps not as visible as that of the original author. Still, intuitively, I sort of think it should have been the other way around. And so this is actually becoming a little more interesting when we apply the bootstrap consensus tree method. We're pulling the results for many individual cluster analyses. We now see that we don't really seem to have three groups as with the originals. We have four. We have two different Galdoses, including one Galdos translated by one particular translator, and of course the other two authors as well. There are other functions in Stylo, and perhaps some of you will be happy to know that the function that we call oppose actually does not deal with very frequent words. Let me explain. Oppose needs two subfolders. By default, they are called primary underscore set and secondary underscore set. Optionally, you can also use a third subfolder that you call test set. It's not necessary. Now, oppose works differently than Stylo. It does not simply count words and it doesn't look for the most frequent words. Instead, it cuts each text that is being studied into equal sized samples, and then it looks for words that behave like that. That is, of course, the black box is the entire text, and here are our samples. It's divided with the red vertical lines. Now we're looking for words in oppose. We're looking for words that behave like this, that doesn't matter how often they're used. What we want to see is that they appear more or less consistently throughout the text. And we're not looking for words that might be just as numerous, but whose usage is limited to one or two samples of in a given text. Okay, so let's do a pretty little experiment with oppose this time. It may seem crazy, but don't be scared. So I'm going to build this experiment in the same way. I'm going to use the original text in Spanish, the same ones that I've been using, Galdos, Ibanez, Unamuno, and I will compare those authors. I mean, there are 9 texts with a similar number of translations into Spanish of books by Dickens, Conan Doyle, George Eliot, Hawthorne, Anthony Hope, and Robert Louis Stevenson. Why? Well, to see if there are some words which may seem more natural in text originally written in Spanish, and whether there are some other words that may be more natural in Spanish translations of English texts. To simplify things perhaps excessively, this is in a way a study of what we call translationese in Spanish. That is the special kind of language that is sort of forced upon the target language by cultural or linguistic elements of of the original culture and the original language. So the first stage will be to find whether there are words that are characteristic and consistently used by Spanish authors, like the three that we have here, and to see whether there are some other words that consistently appear in translations of English literature. And then the second stage will be to use a test set of a single Spanish translation of a book by Alexandre Dumas, translated from the French. And here we will try to see if a text translated into Spanish from the French seems more like original Spanish literature or like translations from another language. All right? So let's take a look what happens. Well, first we get those words characteristic for our selection of originally Spanish texts, and another list characteristic for the English text translated into Spanish that we used. Now, I cannot really tell as well as you can, but I sort of feel that the list of originally Spanish words are somehow, nicer. We have don and doña, and we have familia, and I think we have novio and muchacha, and obviously local, and there is also military, and there's money, and there's enthusiasm. Now, when we look at the translations of English texts, well, the first thing that we see is that there's a lot of answering and replying in the text. Apparently, the Spanish translators of English texts were perhaps a little too faithful in translating some not very obvious elements in the text. Obviously, we have caballero, which I understand stands for gentleman. There is Inglaterra and Ingles. And then there is, I think, some subjunctive mood as well, which is obviously a reflection of typically Anglo-Saxon hedging in speech. I think this is perhaps very obvious, but I think it's also pretty interesting that a silly computer can do something like that. Okay, so part one has been done. Let's now see what happens when we try to see if a translation from another language will be more like the Spanish originals. After all, we're dealing with a book from the French, also a Romance language, so perhaps that would suggest for us to expect a closer similarity of the French translations with of the translations from the French with the Spanish originals, or perhaps there is some sort of translation universal here, and the translation from the French will be more similar to other translations. We do this by using a little diagram which shows the proportions of words from the translations, they are here, and the proportions of the words in the originals, and they are here. So obviously each sample that we obtained, remember, in Oppose the texts are divided into equal size samples. Each sample is placed on the graph depending on the number of the words characteristic for the originals and characteristic for translations. Now, the first thing that we see is that those words are pretty good at identifying which texts are translations and which texts are originals. The blue crosses is our test set, our test case. It's the Dumas translation into Spanish. And, the result is perhaps not very sensational. It sort of shows that, there is perhaps a slightly greater proximity of the translations from the French to the translations from the English. However, more often than not, the samples from the translation from the French are midway between translations from the English and originals. I think it's a fairly interesting result. Okay, and now the final function of Stylo that I will have time to present to you today. It's called roll and classify. It's a special case of counting most frequent words, where we will be looking at traces of different authors in just one text. As I said, it also uses very frequent words. It splits text into equal size samples, and we will be needing two subfolders. One is by default called reference set. This is where we put the individual texts by the candidate authors, by the authors who might have collaborated on the text we're studying. And the test set is where we put the single collaborative text that was, or that we believe was, written by two or more authors. And we'll be looking at into a single text for traces of collaboration by more than one author. Let's see how it's done. And I'll use the example of a case I studied a couple of years ago. It's the story of the Polish translation of Virginia Woolf's early novel, Night and Day. It's still, according to Virginia Woolf herself, a very traditional late Victorian romance. And perhaps this is why, even though Virginia Woolf's been dead for such a long time, that this novel was only translated into Polish in something like 2010. It's also slightly a sad story. The translation began by the lady on the left, Anna Kołyszko, a very eminent Polish translator, who became very ill while translating the novel and died very soon and very unexpectedly. The manuscript was obviously taken over by her publisher, and the publisher asked Magda Heidel, the lady on the right, a very good colleague and friend of mine, a very good translator, and also a Virginia Woolf scholar, as you can see, the perfect person to continue the job. And Magda was asked to complete the translation, and specifically to make it stylistically uniform so that the readers wouldn't know where one translator replaced the other. The moment I heard about this, I called Magda on the phone and begged her, first of all, not to tell me where the change took place, and to send me the final version to see if Rolling Classify can find the exact spot of where one translator took over from another. Obviously, my reference test included other translations by Anna Kołyszko and other translations by Magda Heidel. So when I fed all that into my computer and run the analysis, the result looked like that. Let me explain. Text. This is a sequence of samples starting from the beginning of the text at 0 and ending somewhere beyond 150,000 words. That is the entire length of the novel, and we're looking here at the sequence of those little samples from the text. The samples were taken at 5,000 words, and the author whose signal is stronger appears in this bottom patch in the diagram. Red is for the first translator, Anna. and green is for Magda, who completed the translation. You can see that while in more or less 2/3 of the novel, the signal is very mixed. In this section, it looks more like Anna. In this short section, this looks a little more like Magda, and there's a bigger Magda fragment here. Again, sorry about that. Again, replaced by the stronger signal of Anna, especially visible in this section. But at one point, after 2/3 of the novel, the signal of Anna Kołyszko all but disappears. And it especially stops being seen at all somewhere around here. Well, that was also the beginning of chapter 26. The moment I saw this result, I picked up my phone again and I called my friend and told her, chapter 26, right? There was a silence on the line, and then she said, yes. And we wrote a nice publication about it. So that is, I think, quite a story. I would not have perhaps been brave enough to actually undertake this job if I had seen the amount of modifications that the second translator, Magda, made on the first part of the novel translated by Anna Kołyszko. Look at that. There are places where sentences are being completely rewritten. And yet, despite all those modifications, Rolling Classify stylometry was able to pinpoint fairly well where the change took place. So, which gives us another element to the view of what happens to stylometry in original and translation. When we're dealing with the same text translated by the same translators, here the signal of the translator is very visible. Okay, so to sum up for today, Stylo offers a variety of stylometric analyses, not just of the most frequent words, as you could see, and it's a slowly growing repertoire as we attract more people who are willing to waste their time on writing new functions. It produces high-resolution images that are saved to disk automatically and which can be used in publications if this is where we're going. It also saves word lists on disk. These word lists, by the way, can be manipulated or simply replaced. So if you want, you can pick any list of words and compare groups of texts based on those words. I don't know, colors, swear words, whatever. Stylo can also give you frequency lists, also saved to disk. And it can also produce distant matrices to look at. Normally, of course, you don't need to see them. And also, Stylo produces output which can be used in network analysis, and that is something we will be doing tomorrow. Again, just to repeat the information about Stylo, our GitHub repository is obviously at your disposal, and I hope you become frequent guests. Thank you very much for your patience, and I understand that now, after a short break or not, I will join you live on whatever it is that we'll be using to connect. Thank you.